Welcome to This Is My Architecture. I'm Matt from AWS, and today we're in beautiful Zurich, Switzerland. So have you ever wondered with the Internet of Things, what happens to your thing when there's no internet? Today we're going to be talking with Johan, who's the co-founder of the Things Industries, and he's going to tell us how they enable their customers to connect their things to the AWS cloud. So if you've been watching this series so far, you'll have known that we do 3 to 5 minute videos that kind of dig into the architecture, interesting things that our customers are building on AWS. Today we're going to do something a little different. We're in Zurich, Switzerland, and we're really going to take it to the next level. We're going to do a longer episode where we work with Johan, understand about his architecture. We're going to talk to some of the customers that use this Things network, and we're actually going to see some of these things in the wild so you can really see how things connect to the AWS cloud. So before we start talking about your company, Johan, when you're talking about a device like this, it's not connected to the internet, it's remote, it's maybe hanging above a river or in a forest. How is it actually communicating at long distances?
So the internet as we know it and wireless internet, also used in a lot of Internet of Things applications, uses Wi-Fi or Bluetooth, 3G, 4G. And those are designed for human interfacing, so screens, watching movies, but they can be used for things as well. But it costs a lot of power and the range is short. Okay. For long range and low power communication, you need a protocol or a modulation that is designed specifically for the Internet of Things. And that is LoRa. LoRa is a modulation for long range and very low power communication. And then there's LoRaWAN, that is a software protocol on top of LoRa.
Great, okay, so LoRaWAN is a software protocol. Is this a new protocol? How long has it been around?
It's been out for a few years already.
Okay, but it's just now being used sort of more widely commercially?
Yeah, exactly.
Okay, great. So how long are we talking from a distance perspective? I mean, can this be like 100 meters away, a kilometer away?
The communication is typically in the kilometers. Oh, wow. As long as you have a line of sight, you have coverage. Okay. And it goes really well also through buildings or through obstructions, but that limits the range.
So through the combination of the LoRaWAN protocol, the bit rate, how far you are, and other factors, you can basically control how long the battery lasts.
Exactly. It really depends on the behavior of the device, how much data it is sending, also what kind of measurements the device is doing. But typical LoRaWAN use cases, they run for months or years on a battery or completely autonomous on a solar panel.
Wow, that's amazing. Autonomous or years on a single battery, that's pretty wild. So how does this relate to the work that you're doing? You're the co-founder of the Things Industries, so how does what we discussed so far in LoRa relate to the Things Industries?
Yeah, so in the summer of 2015, we started building the Things network. And that is an open and free-to-use community network, which is basically a LoRaWAN server that everybody can connect a gateway to. So together they build a community network. In the Things Industries is the company building the technology for the Things network, and we also offer private networks with the same technology, but then in a reliable fashion with an SLA, where the customer controls the data flow.
I love that. So there's sort of a community element with the Things network and open network, and also private networks that you offer commercially with the Things Industries.
Exactly.
So now we're going to visit a Swiss software development company called Netcetera, and they built a really interesting solution in Skopje, Macedonia using the Things Network community network. Hi everyone. Thanks for hosting. Nice to meet you. Thanks for being here with us today, guys. So you're the CTO of Netcetera. Tell us about Netcetera. What do you do here?
We do software projects for large customers and also develop a couple of products that we develop ourselves and distribute to customers.
So how did Netcetera get involved in the Things network and more generally LoRaWAN?
Well, it kind of started off as an effort, to trying to level up our own hobby that we were doing. So on this stage, for example, it was me, it was Dani, and a few other guys in Skopje there. So we were all doing, all these little, tiny, interesting electronic stuff and jumping into the IoT sphere and everything. But no one actually tried to make something serious, after that. Okay. And after some time, we learned about this thing called the Things Network, that it's kind of getting its popularity here in Zurich. So our colleagues from Zurich kind of notified us about all that. We asked some people around, and we gathered quite a lot of knowledge and information about it. And we decided to implement the same thing in our office in Skopje as well. Nice. So what we did there is that we expanded the network, which turned out to be quite an easy thing to do. And afterwards, once we had it already there, set it up, we decided to try to experiment and to do some actual things on top of it. And there the idea kind of presented itself. So the city that we live in is kind of struggling with environmental situations, environmental problems.
Skopje, yeah.
Yes, in Skopje, precisely. And we thought that by properly utilizing that technology and combining with something else, that we actually might prove like a solution that may benefit everyone.
And is the data available to anybody? Is it a closed platform?
It is being gathered at one central place, but on top of it, we have a REST API, so anyone can use the data, anyone can gather everything that they want.
Oh, that's great. So it's kind of like a community project.
Yeah.
Great, for the city, Skopje.
Yeah, precisely. So the community piece kind of goes both ways. So anyone can use the data, but anyone can also contribute into producing the data, in the first place.
So you've been doing all these community projects and kind of work and experiments so far. Where do you see this going? How do you see this evolving going forward for Etc.?
With this project, we could build up a lot of experience in this field, and we also built the system as a framework that we can reuse for new customers. So our plan is to offer this for customers, and with this skills that we built up now, it should be a quick thing to apply to new requirements.
Great, so your customers going forward can do their own experiments with the Things Network and with LoRaWAN and innovate quickly with your framework.
Yes, that's it.
That's great, so let's go over to the whiteboard and sort of dig into this in more detail. Let's see not only how your solution was built, but also how the Things Network more generally built their solution. So explain to us how you're sort of collecting the data and what you're doing with it.
Yeah, sure. So Skopje Pulse is comprised as a set of microservices or as building blocks. And the most interesting one here is how we use the Things Network as a way to collect data. So everything starts at the sensors that we have deployed around the city. They're getting the data that we need. They're sending it to the LoRaWAN base stations, the Things Network LoRaWAN base stations. And afterwards, all the data is being sent to the Things Network cloud. Afterwards, we use the option from the Things Network. We use their message brokers as a way to retrieve their data. So everything is being sent to here, and we're getting the data from the broker, which is an MQTT broker, then passing it on to the main web server, which in turn passes everything to a Cassandra database.
Okay, great. So the various LoRaWAN devices communicate with the base station with the gateway, which in turn connects to the Things Network, and then the data is sent using the MQTT protocol into Skopje Pulse. And then, what about these extra microservices? I see like machine learning, I'm guessing, and looks like some additional data sources. Are these accessible as services via your REST API or something?
Yeah, so the story doesn't end here. We want to kind of make usage of the data, of the information that we get. So we have other bits and pieces connected to the system here. One piece is that we try to learn something from the data getter.
So it's machine learning.
Yeah, so it's a machine learning piece. We're kind of extracting correlations. We're predicting what can happen in the future. We have also a statistics service. And also we have 2 other data sources. So we're not solely limited to the Things Network, but to mostly anything that we can use, anything that we can find.
So this is a really cool Things Network use case, and more generally, just a nice IoT use case. So thanks a lot for sharing it with us today. We're here on the outskirts of Zurich, and I'm actually holding an air quality meter in my hand, and it measures the level of CO2 in the air. We're also standing underneath a water level metering device, and that device is actually connected using LoRaWAN to that antenna that we saw on top of the roof earlier today. So I'm here with Reinhard from Decent Labs based in Zurich, and you make all these devices, right?
Yes.
So tell us about Decent Lab.
Yeah, Decent Lab provides LoRaWAN-based sensors which are deployed in large sensor networks for our customers. So our main applications are level metering, either by ultrasonic or pressure sensors for cities, for research or other purposes. And on the other side, we also provide air quality sensors for cities to monitor the air quality and the air pollution.
Great, so these sensors often use LoRa for long-range communications.
Yes.
And if I remember right, they run on just a pair of alkaline C batteries typically, is that correct?
Yeah, that's correct. So our devices have been already from the start off engineered to be low power and wireless. And so with such a battery, the lifetime of our devices is approximately 5 years by sending every 10 minutes to 15 minutes a measurement.
Wow, okay, so by not sending measurements all the time continuously, by going to sleep and by using LoRaWAN and other techniques, you can really save power and last for up to 5 years, you said?
Yes,
wow,
that's
a long
really
time.
impressive.
So I have a bunch of Raspberry Pis and Arduinos. I play with AWS IoT a lot. I also have a lot of sort of cheap sensors at home. What's the difference between like the kind of sensor that you're holding and something that I would typically have with a hobby kit?
Yeah, let's say the story always starts with the requirements by the customers. Sensors always give us a measurement, but our customers have requirements that it measures very accurate, that it's very long lasting, and that it is stable over temperature and over time. So basically, as we are always in harsh environments with our devices by our customers, we even put them in the wastewater system to monitor and to find optimization in the wastewater system.
Great.
And as well in other locations like in rainforests or in city environment where it's harsh due to pollution, to dust. And we have to have it always operational and keep the maintenance low or to zero.
Okay, so high quality sensors, just well built so they stand up to rain, snow, whatever. And even where we're standing right now, if I'm not mistaken, with this sensor, the water where we're standing was like up to my knees just a few months ago, is that right?
Yeah, maybe not up to your knees, but it was quite high.
So you can imagine a situation where perhaps you're connected to the Things network over LoRa and you could trigger some kind of a function that would maybe open a dam and lower the water level, is that right?
Yeah, would be possible.
It makes a lot of sense. I can see how these devices can be really useful in the wild. So.
Yeah.
Great, well thanks for sharing what Decent Lab is up to and how your sensors are helping to monitor environmental conditions. So now we're going to go back to the whiteboard and we're going to learn how these devices like the one behind me actually connect to the AWS network and the Things network. So now that we understand a little bit about LoRa and the Things network, let's dig a little bit more into the architecture and the services that you provide. So there's the Things network community network, but there's also a private network that you offer commercially, is that right?
Exactly. Yeah, so the public community network is a free and open network for everybody to use, and it's very good for prototyping and development. But if you have a business case on top of your solution and you want to offer this to your customer, you want to have a reliable network and you want to have a service level agreement. And for this, we offer, from the Things Industries, we offer private networks.
Great, so Things Industries is your commercial wing, and to have an SLA, you need a fault-tolerant architecture, which means that you have to deploy it, in a way that it'll be resilient and durable, right?
Exactly. Yeah.
So let's talk about that. Let's dig into the AWS architecture. So over here, yeah, I guess these are LoRa devices, is that right?
Exactly. Yeah, so these devices are LoRa devices, and they send LoRa messages from the gateways. So it's a bidirectional. But since LoRa is a radio protocol, all the gateways that are in reach, they receive the messages. So it's actually adding more gateways is also adds fault tolerancy.
Great, so it kind of creates a mesh network to the gateways.
Exactly, yeah.
And I think you say that you actually sell and build gateways. Do you have to use a Things network built gateway to use the Things network private network?
Yeah, so the Things gateway is a very easy to activate and set up LoRaWAN gateway, but you can use any LoRaWAN gateway on the market. Okay,
so you can build your own or buy a third-party one?
Yeah.
Okay, so this LoRa device network connects the gateways, and the gateways in turn connect to the Things server hosted on AWS, is that right?
Yeah, exactly. So the gateways, they have a secure connection with the router, and that is the first component of the Things network server.
Okay, so you have a router, a broker, and a handler. Are these EC2 instances deployed in AWS?
Yeah, so they can be, they can run on one EC2 instance for small private networks, but for bigger networks, you can run them on a separate EC2 instance. And since they are microservices and they can also be deployed in different regions around the world.
Oh great, so it's a loosely coupled architecture of several microservices. Now why would you want to deploy, I understand a multi-AZ architecture, and certainly for high availability you want multiple EC2 instances, but why would you want to deploy in multi-regions?
So you want to keep the latency as short as possible. So these devices are really low power devices. They need to sleep as much as possible. So when they send a message, they stay awake for 1 second or 2 seconds. That's LoRaWAN specification.
It's built into the protocol.
Yeah, it's built in the protocol. So you need the gateway needs to answer if you want to send data back to a device within 2 seconds at most.
So basically, if the router is too far from the device physically, it might not get back the round trip time before the device goes back to sleep.
Exactly. So it helps when you keep everything as close as possible to the gateways. And this is what we allow with this distributed architecture.
That's interesting. So the distributed architecture and the loosely coupled nature of the architecture allows you not only to be highly available, but also to meet the latency demands of the architecture. Okay, very cool. So on deployed on AWS, you said these can be EC2 instances, one or many. How are you actually deploying these? Are you using CloudFormation?
Yeah, we're using CloudFormation to set up the infrastructure. And we offer it in 2 separate ways. First, we have the AWS SaaS marketplace, where people can buy a subscription. And then we use CloudFormation to deploy the network server. You can also deploy the private network in your own AWS account.
Oh, great. I like that flexibility. So you're using AWS Marketplace SaaS billing, so you can kind of pay as you go, and that's a hosted model. It's a multi-tenant SaaS application that the Things Network operates. Is that right?
Exactly.
But customers can also deploy it themselves in their own AWS account.
Yeah.
Okay, great. So how do you actually, I see AWS IoT over here. How is the Things Network actually connecting into AWS IoT?
Yeah, so together with AWS, we built a bridge. And the bridge connects with the Things Network handler, which does encryption and decryption of application payload. And it bridges with AWS IoT, where your devices are stored. So your device registry is here, and also device telemetry, as well as the device shadows that AWS IoT uses. So data flows from the gateway to the router, to the broker, to the handler. And then it's using this bridge, we bridge to AWS IoT.
Okay, so you said device shadows, so device state is stored here, device registry, so the list of devices themselves and some telemetry. I guess it also allows you to connect to some other AWS services. What other services, like where does AWS IoT end and your services begin? Like what, in addition to the routing and the message broking, what other services is the Things Network providing in their infrastructure?
So we implement everything around LoRaWAN, but also to monitor your network, and we have monitoring, we have alerting, we have a graphical user interface where you can see traces of your network and data flowing through your network, and we have auto scaling functionality. So if the load in your network increases, we can automatically scale up, and we can also send you alerts on load.
Great, so monitoring, alerting, high availability.
Yeah.
It really is an IoT platform that kind of extends and enhances the functionality we have.
Yeah,
It's actually really cool. It's like an IoT last mile.
Yeah, it's the last mile of IoT, and it's not IP. So we basically, this is not only a bridge to the AWS ecosystem, but also to IoT devices that don't have an internet connection. Because this is like a really low power radio protocol that
When
we
the
use.
internet ends, you begin.
Yeah.
Very cool. And so, when you're connecting, where do you see customers using AWS services? I see a few services over here. How are they leveraging AWS services in addition to the services that you provide?
So usually what people do is they store the data in DynamoDB or in S3, but also Lambda is very usable for invoking functions based on data that comes in from AWS IoT.
Okay, so yeah, based on some preconditions of a message or whatever, it'll trigger some action and remediation or whatever the case may be.
Yeah.
So a message flows through the system, maybe triggers a Lambda function. Can you actually push data back to the devices? Is this a bidirectional or a unidirectional system?
Yeah, it's bidirectional. Okay. So your application can send data back to a specific device or to a group of devices. You can also broadcast. And we schedule the message until we have an opportunity to send data back to a device.
Oh, because it's low power, so it might be sleeping.
Exactly. So if the device wakes up, we have an opportunity to send data. But there are also some devices that are continuously awake and are always able to receive data. This is, in LoRaWAN, it's class B or class C.
Okay, so I guess they sleep just to really preserve battery.
Yeah.
These batteries last a long time.
Yeah.
Okay, that's great. So high availability is amazing. Being able to queue up and send messages to devices once they wake up is a nice service you provide. The other thing that's really important in a commercial space and enterprise space especially is security. So how do you actually provide end-to-end security for these devices? Are things encrypted, and how are you handling that?
Yeah, so LoRaWAN provides a security mechanism, and this is all handled by the network server. Okay. If you want to have an additional layer of security, you can add the secure element in a device. And with the secure element, you can leverage the AWS IoT encryption and decryption using certificates.
Oh, great. So you can have the Things Network and kind of LoRa-based key management and encryption and decryption and authentication, but you can also use on a device level with certificates AWS IoT?
Yeah, exactly.
Okay, that's another nice way that it kind of extends and enhances our platform.
Yeah.
Well, this is very cool. I really like how the Things Network provides that last mile of connectivity and picks off where the internet leaves off. So, and it's very nice how it enables users to use the cloud and DynamoDB and all this other stuff, while at the same time enabling this low power IoT use case. Very nice architecture. So now that you understand how the Things Network actually works and how it's built and how it integrates with AWS, we're actually at the Things Network Meetup in Zurich. And here they're explaining to a whole community of people how to use the Things Network, kind of what the roadmap's looking like for 2017. And we're also here with Simon from LoTaipan, which is a startup that is building and prototyping devices that work with LoRa protocol and can integrate with the Things Network. So Simon, tell us about this prototype and what are you building?
So we're building a very small prototype. This is actually The end version of it's going to be smaller. This is a bit bigger because it's a prototype.
Okay.
And the idea is that anybody with very little coding knowledge can then use and program an end device.
Cool.
So maybe right now, if you want to program an end device, you have to write hundreds of lines of code. It's very complicated.
Yeah.
I'm a lawyer, I can't do it. But the end idea is that at the end, with a bit of JavaScript code, 5 lines of JavaScript code, you can prototype a device in an afternoon, add a little battery to it, put it out in the field, and it works for years.
Oh, fantastic.
That's the idea.
So basically you're enabling like the maker community,
Yes.
the ecosystem to,
Of course.
to code easily, to really provision these LoRa nodes.
Yes, yes.
So how much memory is on one of those things?
So on this thing, this is the new Murata module. It's the smallest module, I believe. It's a very fast-changing market on the market, so it's a small chip.
Yeah.
And there's only 20 Ks of RAM on it. So yeah, it's kind of hard to do that on our side, but we're
So
giving our
there's
best.
20K of RAM, but you're
Yeah.
still able to code it with JavaScript, right?
Yes, yes. It's a JavaScript for microcontrollers. It's a reduced version, but the most functions you can use.
And this is just a prototype, so it's like 5 centimeters, but like how big will it be when you go?
So the idea in the end, we have a design now that's going to be about a bit under 4 centimeters and even a bit less wide. So
Wow.
the idea might be that you could even put it in a little bicycle.
Yeah.
In the bicycle frame, add the GPS module, and then you can prototype your own bicycle theft device. That's one of the use case, for example.
Fantastic.
Yeah.
So this is the Things Network at its best. You know, it's really working with startups that are enabling the community to play with LoRa, to play with the Things Network, and then eventually they build commercial applications that can run on the Things Industries private network and backhaul into AWS. So it's great to see the community efforts, startups, lawyers who are building prototypes that are this small. So, really nice work.
Thank you very much.
Yeah, thanks for showing it.
Great.